Okay. Picking up where we left off in lesson 9.1. And it's not up here because of the way the recording works, but you have y equals x squared down in your notes, right?
Yes.
Okay. And so we talked about when we graphed y equals x squared that for what we're doing right now, we're just using an xy chart.
Yeah.
And filling those values into graphing. And so that's what we're going to do with this one. So if I set up an xy chart, what kind of x values did we use?
0, 1, 2.
Yeah, 0, 1, 2. And if you recall, those x values of 0, 1, 2, that would give me the right half. Then we can flip it over to get the left half. Okay, so now the key is, how do we do this math? Well, 0 is the easy part. If I put in 0, now keep in mind it says negative 3x squared, that means I'm doing negative 3 times 0 squared. 0 squared is 0 times anything is 0. Okay, try the next one. Negative 3 times 1 squared. Remember when you do this, do the exponent first and then multiply.
It's going to be just negative 3.
Yep. 1 times 1 is 1, and negative 3 times 1 is negative 3. Okay. Put in 2. So negative 3 times 2 squared.
12, negative 12.
Yep. 2 times 2 is 4, and negative 3 times 4 is negative 12. Okay, so we're going to graph these. 0, 0 is still 0, 0. And it's always going to remain 0, 0 until we start having plus or minus here. If it's just something x squared, 0, 0. 1, negative 3 says to go over 1, down 3. Okay. 2, negative 12 says to go where?
Over 2 down 12.
Over 2, down 12. It's not. Do you notice how I kind of estimated 12 down below?
Yeah, that's what I did.
I just kind of, my dots kind of indicate me counting. It's not exactly, but it's good enough. I was looking at my notes from previously, and I actually labeled and counted by 2s instead, but it's fine. Now, what about the other half of the graph?
You just flip it.
Yeah. We did have a point at 1, negative 3. Now it's going to be negative 1, negative 3. Or this point was 1 to the right, so we need 1 point to the left. And then, honestly, whoops. I'm going to put a point about down there.
Very strange looking.
Okay. Oops. Why is it strange looking? Okay, it's skinny. Why is it skinny?
It's so tall.
Why is it so tall?
Because it's negative, so it goes up to 12.
Okay. What part of the equation made this tall and skinny?
The A value.
The A value. And notice my A value here is 3. And since 3 is a number bigger than 1, or I forget how it says here. For algebra 2, I teach it's a number bigger than 1. Here, and it says the larger the number, the narrower the parabola. So I don't have it specific. But basically, the number is bigger than 1. It's gonna be stretching it up. Okay? And then what made it be upside down?
Oh, it's negative.
The negative. Okay? That made it be, actually I shouldn't say upside down. I should say open down. How's that?
Downward.
Okay. Now, before we move on, You have to do some domain and range in homework. So we need to talk about domain and range. Domain refers to which values?
X values.
X values. So X values, here's my x-axis. How far left and right does this graph go if it continues infinitely? Forever, yes.
All real numbers.
And the official wording for forever is all real numbers. I'm going to use a number sign, apostrophe S. It's not all real hashtags, it's all real numbers. Just before I get the question, why are you writing a hashtag?
Well, I did that one.
Did you? See, I almost did, but I tried to get one normal one. Okay, range. Range refers to the
Y values.
y values. So then on the y-axis, how low and high does my graph go?
It goes smaller than 0.
Okay, good. Smaller than 0. Mathematical word for smaller than 0 is
It's equal to or less than 0.
less than or equal to 0. Yep. And we know it's less than or equal to 0 because
It's negative and it starts at
Yeah.
0, 0.
my high point is at 0, right? My vertex, which this vertex is because it's the high point, it's a max. Yeah, so if you're asked in homework, is it a max or a min? Well, it's at the top. It's a max. And my vertex in this case was 0, 0. Okay? Ready to try the next one? She's like, do I have a choice? And you know the answer to that, so we'll just keep moving along. Okay, we've got 2 graphs to do, and then you can have some work done. So, works for me. Okay, y equals 1/2 x squared.
Yes. Okay. Gotta make the X and Y chart.
Okay, so xy chart. What numbers do we like in our xy chart?
0, 1, 2.
Normally I like 0, 1, 2. I still do to an extent, except how do you feel about graphing fractions?
Well, it's fine. Just do half of it.
I mean, I guess it just kind of, makes your graph list accurate. Kind of depends on what you're doing.
Yeah.
So, because we prefer to be able to graph with whole numbers, because it's 1/2, I want to make sure that I'm using numbers that when I divide them by 2, they're still going to work out nicely. So we usually say multiples of 2. When I say multiples, I'm talking 2, 4, 6, 8, so on and so forth. Because when I put in odds, like 1, 3, 5, when I square it and then divide by 2, I'm going to get a fraction or decimal. So you can still use 0, 1, 2 here. I'm not saying you can't. Your graph is a little less precise, but what I always teach is multiples of the denominator. So since my denominator is 2, I'm going to say, and always 0, of course, 0, 2, 4, so on and so forth. Okay, put in 0.
0 squared.
And what is 1/2 times 0 squared?
0.
0, because 0 times anything is 0. Okay. One half times 2 squared.
Hold on. 2.
Because 2 squared
Yeah.
is 2 times 2, which is 4.
Yeah.
And then easiest for me to say is, okay, what is half of 4? Half of 4 is 2. And then we're doing 1/2 times 4 squared.
8.
Because 4 squared, 4 times 4 is 16. And half of 16, so 16 divided by 2, if you will, is 8. Now, okay, you may have already started graphing, but predict. Is this parabola going to open up or down?
Up.
Up because it is
Positive.
positive. Is it going to be regular size, tall and skinny, short and wide?
Short. Wide.
Because this 1/2 is a number less than 1, so like a number between 0 and 1, it's going to be a wider one, is essentially. Okay, so if you haven't already graphed it, graph it. 0, 0, 2, 2. Right 2, up 2. Right 4, up 8. These are some old graphs because I always now use 10 by 10 graphs. This is weird to have a, 7 by 7? Okay, there's the right side of my graph. Since I have 1 here that's 2 right, I'm going to make the equivalent 2 left. I have 1 over here that's 4 right, I'm going to make the equivalent 4 left. Okay. Okay, so you can compare that to our original one from yesterday, and that is wider than yesterday. You can compare it to the last one we just did, which was upside down, but it was skinnier. Okay? One more. Y equals negative 1/3 x squared plus 6. I'm going to make you work a little harder on this one. Still going to use my XY chart. Thoughts on X's? Thoughts on XY? Thoughts on X's?
Well, it's going to be multiples of 3, right?
Yeah.
So
My denominator is 3, so I'm going to encourage multiples of 3.
0, 3, 6.
Yep, you got it. 0, 3, 6. And if we wanted to put in negatives, we could use negative 3, negative 6. In this case, we're just reflecting them because all these graphs are centered on the x-axis, which I just realized I'm not drawing in. So as I look at my notes, I'm looking back, and I drew in, we haven't really talked about it as much, the axis of symmetry. The axis of symmetry on these, because there's just x squared terms, is just that center.
Yeah.
Because until we have an x term, if we just have x squareds in number terms, our axis of symmetry is the center y-axis.
Yeah.
Okay, let's put in 0.
Well, that's just going to be 0.
The whole thing is 0?
Well, I don't know if it's plus 6. It's going to be 6 then.
Right? 0 squared is 0, times a negative third is still 0, but 0 plus 6 is 6. Okay? 3.
3 squared times 1 plus 6.
So 3 squared is
9.
9. Negative 1/3 times 9. What is a third of 9?
3.
Yeah, because it's when I say what is a third of something, I'm saying divide it by 3.
Yeah.
And a negative times a positive makes it a
Negative.
-3. So negative 3 plus 6 is
9. Well, no. Negative 3 plus 6 is 3.
there you go, 3. So now I have the ordered pair 3, 3. Now we're going to put in 6. We have 1/3 times 6 squared plus 6. What is 6 squared?
36.
36. Now you're doing a third of 36.
12.
12, and negative times positive makes it a
Negative.
negative. Negative 12 plus 6?
Is 6. Well, negative 6.
Negative 6. Okay.
Yep.
What can you predict about this graph?
Well, and then it's going to be that and upside down.
Okay. That and upside down. Do you know what this plus 6 does to the graph?
Oh, well,
It's still going to be fat and upside down. Let's look at what the plus 6 does. Let's graph them. Well, notice, here's the deal. My past 3 parabolas have all had a 0, 0.
Oh, yeah.
Now I have a 0, 6. So what that means is my parabola just moved up 6. It's no longer centered at 0, 0. Okay? If it was a minus 6, my parabola would have moved down 6. So 3, 3, right 3, up 3, and 6, negative 6. Right 6, down 6. Put the same equivalent points on the left side. And in Makayle's words, we have a fat upside down parabola, and then the plus 6 moved it up 6.
Yes.
Okay?
I'm really bad at drawing these. I like pointing.
I think they're just fine. As long as it's not an intentional point, I get it. I mean, mine kind of, I feel like, are kind of pointy. I feel like I have a problem drawing them on the BenQ here, so. Okay. Your homework. I know you said you've already started it. Is lesson 9.1 in Math Excel. And you can work on it.